All right, welcome to AP Calculus AB. This is an initial value problem of second order, and so the second order comes into play when we're given, you see, the second derivative. So we are wanting to find the particular solution, that is f of x, the original function, given the following. Here is its second derivative, and here is the initial value of the original function. And we also have some information about the first derivative, which we're going to need in order to find all the constants that we need for this particular solution. So let's just get right into it. What we do first, of course, is we integrate to get the first derivative. So you just think about this as, let's integrate this with respect to x, integrate this side with respect to x. And if we integrate the second derivative, we get the first derivative. So if we take the antiderivative of this side, that is going to be x to the fourth there, bump that up, and then divide what's already there by 4 of the coefficient, right? And then this is just a 10, so that becomes a 10x. And of course, we have to add this c. There might be a constant there, right, that we didn't know of. Now at this point, we want to solve for c right away. Remember, when we're given additional conditions for these kind of separable differential equations we're solving, we're given initial conditions, we need to solve for this constant right away, and this is the one we want to focus on, isn't it? Do you see that? So f, it says f prime of 1. See, we're given that, and that's when, of course, the x equals 1, right? And so if we fill in the 1, and we understand that this is actually what? -5. You see that? So I'm going to put a -5 there. And here then is what we have to put in to find c. There's your y value, there's your x value, and so on. Okay? So a little fast forward here, you evaluate this, c is going to be equal to 0. Okay? So with c equal to 0, let's just erase some of this stuff for some room, and I am going to now plus 0 here is the actual particular first derivative. See that? So I've taken care of this, check. Okay? We've used that. And it's really plus 0, which of course we don't need to put in there. So now that's order 1. Order 2, let's integrate again. And so here we go. We're going to integrate this side with respect to x as well as this side with respect to x. And what do we get? Well, if you integrate a first derivative, you're now going to get your original function. That's the original function we're going to be finding. And so here we're going to bump that exponent up, and we're going to divide the coefficient that's already there by 5, which is 20 divided by 4 times 5, which is actually 20. Or think of it like this, 1/4, right, times 20, that's what this is, and multiply by 1/5, so that's 20 over 20, right? And so over here then, we're going to bump this up. This is a 1 right now. We're going to bump that up to 2, and we're going to divide this by 2. And so that's going to be minus 5x squared. You see that? Minus 5x squared. Plus d. Now, we usually use c, but we've already used c, so let's use d in case you're asked later in the question, what is c, what is d? Right? So this is now the form for the original equation, and given initial conditions here, right, for this, so now what we're going to do is we're going to plug these values in, and of course, f of x is 1. And so is y. So this is 20 over 20 is just 1 times 1 to the 5 minus 5 times 1 plus d. Okay? And so what do we get there for d? We have 1 here, got a 5 over there. And so d is 5, looks like. And so what that means is the original function, and again I'll just kind of erase this stuff here. The original function, oh, what was that, plus or minus? Plus. Okay, so the original function is going to be plus 5 here for the constant. Okay, that's what our answer is. That is the original, the particular solution, f of x, given this differential equation here. Okay, initial value problem, second order. Now how can we check this? Just one quick final thing here. Let's check this by taking the finding the second derivative of this, right? So f of x, again, is, you're not going to want to leave that 20 over 20 there, I guess, right? Sorry, that's just going to be a 1. So you may as well get rid of that. Don't leave that in there. But that's going to be, so f of x is x to the 5th minus 5x squared plus 5. The first derivative there is going to be 5x to the 4th minus 10x, which we saw there earlier, and take the derivative again to get the original function for x there, and that's going to be 20x cubed minus 10. And is that the same thing that we started with? It sure is. So we do have the correct answer. Okay, so that's kind of a beefed up initial value problem where you have a couple sets of constants and you plug in the info. Okay, and there's that question.